Okay, in that case, let me share my screen first. Okay, can you see? Can see my screen?
Oh yeah, what do you say? No, it isn't.
Okay, can you?
Yeah,
Sorry.
now I can.
Okay. Then can I get you to mark first? Okay, just mark the MCQ first.
Wait, that isn't the paper you gave me.
Oh, this isn't the paper?
No, it's the formula and equation, the ionic one.
Oh. Do you receive the booklet? It should look something like this.
Oh yeah.
Okay. Do you do this? You're supposed to do this.
Oh no, I didn't do that.
Oh, you didn't do this?
No. I didn't know
okay.
it was supposed to do.
Okay, well. Give me a minute. Okay. Give me a minute. Okay. Since you never do, right? Can I just get you have your that booklet with you now?
Yeah.
Okay, then can I get you to do the questions now?
What topic?
The atomic structure.
Oh, okay.
Yeah, just do we do page by page. So once you're done with the first page, I'll go through with you.
Okay.
Okay, are you able to do the first page?
Yeah, almost. I don't know how to do the first question.
Okay, never mind first. Okay, so can I get your answer? What's your answer for the first question?
B.
You put B, is it?
Yeah.
Okay. Okay, then your second question, your answer?
B.
Okay, then third one?
A.
Okay, you put A. Okay, never mind. So first question you don't know how to do. Okay. So how do you get B? Do you guess or something?
I guessed.
Okay. So this one, right, it actually involves a bit of math or algebra. Okay. So there are two isotopes, C12 and C13. Okay. So the total composition of isotopes, right, will make up 100%. Okay. So how do you know the formula to find the relative atomic mass?
Proton plus neutral.
Okay, not really. Okay, so this relative atomic mass, right, to find it, so you know that there's isotopes. Okay, relative atomic mass is the average mass of all isotopes. Okay, simply put it. Okay, so to find the average mass, right, you have to take into account the percentage of it. So for example, C12, right, it may exist as 10%. Then C13 will exist as 90%. This is just an example. So the relative abundance of it is being taken account when you're calculating relative atomic mass.
Yeah.
So what's the formula for it, right? Is normally you take the atomic number 12 times the percentage or the relative abundance plus you take 13 times percentage.
Oh, how do you know it's 10% and 90%?
This is just an example.
Oh, okay.
Oh yeah, this is just an example. Okay. So basically, what this question asking, right, is to find this percentage or the ratio between C12 and C13.
Okay.
Okay. So to do that, right, let me erase this. To do that, we need to use a bit of algebra. So we take X as the percentage of C12.
Yeah.
Okay. So we take 12 times X plus 13 times 1 minus X. Because if X is 20%, then 13, okay, if C12 has 20%, then 13 has 80%. So 1, it basically means 100%, then you minus X.
Okay.
This one, understand?
Yeah.
Okay, so this will be equals to 12.2. So this is a bit of algebra, so if it's 12x plus 13 minus 13x, then you'll get minus x equals to minus 0.8. So x equals 0.8. So 0.8 is 80%. Okay, that means 12C is to 13C will be 80% is to 20%. That means it's 4 is to 1. So the answer is B.
Oh, okay.
Can you understand?
Yeah.
Okay, then okay, I'm moving on to question 3. What are the likely proton numbers for X and Y? Okay, how many electrons, right, does X have? X is the circle one, the clear one, not the solid one.
What? 6.
Okay, X has 6. How about Y? How many does Y have? How many electrons, valence electrons does Y have?
7.
7. Okay. Okay, so you choose A, right? Okay, because why this is wrong, right? Is because this only shows the valence electrons. So okay, you got the concept right, where proton number equals to electron number. However, the diagram does not show all the electrons that the compound have, or the X and Y elements have. So if you do the electronic configuration, right, if it has 6 protons, it'll be 2, 4. Means it will only have 4 valence electrons. But you know X has 6.
Yeah.
Same for Y. If Y has only 7 protons, That means it will only have 7 electrons. If 7 electrons, it will be 2, 5. That means 5 valence, but you know Y has 7 valence. So the correct answer in this case will be C, 2, 6. This X has 6 valence electron, while Y will have 2, 8, 7, 17. So 7 valence electrons. That's why the answer is C.
Okay, yeah.
Can you understand?
Yeah.
Okay, can you do the next page? Okay, you done?
Um, yeah.
Okay, can I get your answers for 4, 5, 6?
4 is B, 5 is A, 6 is B.
4 is, you put D, right?
Huh? No, 4 is B.
4 is B. 5 A, and then 6 is C.
I put A.
Okay, 6 you put A. Okay. So 4 and 5 you got it correct. Okay, let's look at 6. Oh, okay. Actually, 6 you can skip the question, I realized. Because 6, right, the question isn't actually asking for anything. There isn't a question per se. You just have the diagram there.
Okay.
Okay. Okay, can I get you to flip to question 19? It should be on page 29 of the booklet, question 19. Okay, can I get you to do that page? The page 29. Hello, can you still hear me?
Yeah.
Can, have you done that page?
1 minute.
Which question are you at now?
23.
23, okay, can. Okay, you done?
Yeah.
Okay. Can I get your answers?
I don't have to do 21.
Don't know how to do 21. How about the rest?
Yeah, I know how to do.
As in, do you have an answer for them, or you just?
I don't. In 19 I got B.
Sorry, can't hear you. Can you like speak louder?
19 I got B.
19, you got D.
B.
Or B for boy. How about 20?
C.
Okay, 20 C. 21 don't know.
Yeah, don't know.
Okay, 21 is okay. Never mind. 22?
22 I got D.
Okay, you put D. How about 23?
23 I got D.
D for dog?
Yeah.
Okay, can. Okay, so only 21 and 22, you got it wrong. Okay, 21, right, is similar to the question we did just now. So element P with a relative atomic mass of 152.4 exists as these three isotopes. So we need to use the formula as before. So 150, you have to times 60%, 60 over 100. Okay, then you plus. So if you do not know the percentage, right, you take it as X. Okay, so 155 times X. Then you plus 157 times. Okay, this one, right, will not be X anymore. Okay, so after 60%, how many percent do you have left?
40.
40. So you know that X plus Y equals to 40%. Correct?
Yeah.
So instead of 1 minus X here, it will be 0.4 minus X. Okay, this should roughly give you 90 plus 155X plus 62.8 minus 157X equals to 152.4. Okay, then if you do some math, minus 2x equals to 0.4 minus 0.4. X will just be equals to 0.2. Okay, so if x is 0.2, that means x is 20%. So what is the value of x? It's 20. Answer C. Can you understand?
Yeah.
Okay, we move on to question 22. Ion with a charge 3 plus has 18 electrons. If you form a charge of 3 plus, what does that mean? Have you gain or lose electrons?
Lose.
Okay, you lose 3 electrons.
Yeah.
Okay, so how many electrons does this atom have?
Originally.
Yes, originally.
15.
Sorry?
15.
Sorry, 18 is it, you said?
15. 1 5.
Or 15? Okay. You see, after you lose electrons, you have 18 left.
Oh,
So to find original, you have to add back 3, not minus 3.
so 21.
Okay, so you have 21 electrons. Okay, so 21 electrons, that means 21 proton. How many neutrons? 50 minus 21 will just give you 29. So the answer is C. Can?
Yeah.
Can. Okay, then I just get you to do next page, the 24 to 27, 24 to 20, oh, just 24 and 25. You able to do 24, 25?
Yeah.
What's your answer?
I haven't do 20. Wait, 25, I'm halfway doing it.
Okay.
On 24 is A, 25 is A.
24A, 25 is B.
A.
A and C, is it?
A and A.
Oh, you put A and A. Okay. Okay, 25, your answer wrong. Okay, we go through 25. Chlorine, 2 isotopes, 35, 37. What's the, okay, do you know what is isotopes?
Yeah, same proton but different neutron number.
Okay, so elements of, okay, they are the same elements, same element with different neutron. Okay, so you put A. Why do you think they have different electrons?
Oh.
Or why do you think they do not have 18 electrons?
But doesn't both of them have 18 electrons because Cl minus? So
Okay, sorry, can you say that again?
don't both of them have the same number of electrons because Cl minus? So gain 1.
Okay, yeah, both of them have the same number of electrons.
18.
Okay, so Cl minus, that means you gain 1. So you have 18 electrons,
Yeah.
right?
Yeah.
So they're asking you, okay, sorry. So for this one, right, Cl minus has 18 electrons, correct. However, the question is saying atom. So atom, right, haven't gain or lose.
Oh.
So these are 17 electrons only.
Okay.
Okay, then B is incorrect because 17 plus a total of 35 protons, 17 plus 17 will just be 34, not 35. Okay, so because proton number equals to electron number. Okay, and proton never change. Okay, too few neutrons than an atom with the heavier isotope. So 35, 37 with minus is just 2 lah. Okay, that's why the answer is C. Okay, same number of neutrons. Okay, this they should have same number of protons, not neutrons. Can? Okay, then I can get you to do the structured questions. Drew 26 first. Okay, you done with question 26, Alice?
Yeah.
Okay, okay, can I get your answer? Okay, 26A, what do you put?
For the first one, I wrote 113, a proton number.
113, yeah.
For, proton.
Okay, B?
For the number of neutrons, I put 173. For A,
Oh, 173. Okay,
B, I wrote that it has 3 valence electrons and 7 electron shells.
3 valence, 7 electron shells. Okay, how about C?
I wrote that it means that the same element of methonium has the same number of protons but different number of neutrons.
Same number. Okay, very good, very good. Okay, so that's all correct. How about 27? Have you done 27?
Yeah.
Okay, what's the answer?
first is P and T.
P and T. B?
B. B, I wrote Q.
Okay, B you wrote Q. How about C?
C, I wrote R and S.
R and S. How about D?
D, I wrote Q.
Q again. Okay.
Yeah.
How about E?
E, I wrote which one? R and S.
R and S. Okay, can. Okay, so looking at this, B is sorry. Okay, B is wrong. Which particle is an anion of charge 2 minus? You put Q. If you look at Q, right, number of protons, number of electrons is the same. This means that it hasn't gained or lost. It is still an atom, and an atom will not have a charge. Okay, so you have to find a particle that has already lost two or gained 2 electrons in this case to form 2 minus. Okay, so the correct answer here should be S, because 2 8 is 8 is 2 6, 10 is 2 8 2 8. That means you plus 2 electrons. You gain 2 electrons, that you form a charge of 2 minus. So this should be S. Can?
Yeah.
Okay, from the same group. Same group, that means they have the valence electrons, same or different?
Valence, same.
Okay, so same group, right, basically means they have the same number of valence electrons. Okay, so let me erase everything of this. You put R and S. R has 2, 8, 7, while S has 2, 6. Is it the same?
No.
So R and S, they have different number of valence electrons. Can you see?
Yeah. Oh, is
So
it?
they are not in the same group.
Is it Q and S?
Yes, the answer should be Q and S. Okay, Q and S. Okay, question D is also not Q. So which particle exists in an arrangement that allows it to be an electrical conductor in the solid state? Okay, this comes down to chemical bonding already. What kind of element or what kind of particle, right, can conduct electricity in solid states?
Metallic.
Metallic, okay, metals. So to find which one is metal, right, basically you need to find which group they are in. If you have 6 valence, 2, 4, 2, 5, 2, 8, 6, 2, 2, 5. Okay. Does this help you? Does this tell you anything about their metal or not?
No.
Okay. So which particle can exist? Okay, this one, right, will require a bit more thinking. Okay. So if you go and look at your periodic table, right, you identify all the elements. Okay. So P, right, if you look, which one has 7 protons? This will be nitrogen. Q will be sulfur. R will be chlorine. T is S first, sorry. S is oxygen. T is also nitrogen. And then U is, what is U?
U is carbon.
carbon. Okay, so which particle can exist in an arrangement that allows it to be an electrical conductor in the solid state? So this one, right, you need to know about your giant covalent compounds. Okay, carbon, right, can make graphite, and graphite can conduct electricity in solid state. The rest, right, the rest will not form compounds that will allow you to conduct electricity in the solid state. So for this case, right, only C is the answer. Sorry, U, which is carbon.
Oh, okay.
Can I say?
Yeah.
Nah, okay. Then for E, you put RN. Okay, eRNS is correct. Okay, so this question, understand how to do? Can I?
Yeah.
No.
Yeah, can.
So I can't really hear you.
Can.
Okay. Okay. Have you done 28 or can you do 28 now?
Okay.
Okay, let me know once you're done, okay?
Yeah. I'm done.
Okay. Okay, 28. What's your answer?
28. For the first one, I put 11.01%.
11 point?
01%.
Okay. How about B?
B, I put 31.8%.
21.8.
31.
31.
Yeah.
Okay, we are using the values in table 1.2. Calculate the average mass. Okay, I think this one you may have calculated wrongly. Okay, so how you should calculate, right, is you take 24 times 78.99 over 100 plus 25 times plus 25 times 10 over 100 plus 26 times 11.01 over 100. Okay, do you do this?
Yeah.
Okay, can you try type it into the calculator again? Maybe you type something wrongly.
Oh, I got 24.3.
Yeah, okay, this should be 24.3, not 31, 30.1 or something. Okay, how about have you done 29?
Yeah.
Okay, what's the answer?
D and E.
29.
Yeah, I don't know how to do D and E for 29.
Oh, don't know how to do D and E. Okay, A, B, C, what's the answer? Can I get first?
A is 4, B is 3, -2, -2.
Okay. Sorry?
Yeah. Huh?
Okay, like that only. Okay, state the number of electron shells in a calcium ion. Calcium ion, right? That means you lose 2 electron. Correct? So if you see calcium, right? Originally it has 4 shells. However, if you lose 2 electrons, you lose your outermost shell. Can you understand?
Yeah.
Okay. So okay, if you understand, I don't draw. So if you lose your outermost shell, you will have 3 shells left. So for A, this should be 3, not 4.
For B, it's 4. I just
Or
checked.
for B, you put 4.
Yeah.
Yeah, okay. B should be 4.
Yeah.
Okay, then look at D, state the oxidation state of carbon. Oxidation state, right, very simply means the charge. Okay, so hydrogen, right, will always be +1. Okay, if hydrogen is +1, what's the charge of carbon here?
Um, so +4.
Would it be +4? Yeah, I plus, okay, got 4 here, right? So I +4 +4 equals to +8. But compounds are always neutral.
Minus.
It should be -4. Okay, let's state the number of oxygen molecules required. Okay, this one requires you to write the chemical equation first. Do you know what is combustion?
Burning.
Okay, combustion, right, basically means burn in oxygen. So the equation will be CH4 plus O2. What are the products of combustion?
Carbon dioxide.
And
Um, hydro.
okay, you get water, H2O. Okay, so how many oxygen molecules, right? You need to balance this equation. Okay, can you balance it and then tell me the answer?
CH4 it's
Sorry, can you say again?
CH4 plus 2O2 then CO2 plus 2H2O.
Okay, very good. So how many, what's the number of oxygen molecules needed?
Um, 4 times
It's just this one, two.
oh,
It's just two. Because you need CH4 plus 2O2. So you need two oxygen molecules. Can you understand? Now, okay, then I get you to do one more question. Let me see. Okay, can you do 32?
So my week's link.
Answer 18.
Is the answer 18? Okay, x equals 18 is correct. Okay, very good. Okay, in that case, so atomic structure, right? Do you have anything you might want to ask? You're not sure about atomic structure?
No.
Don't have. In that case, we go to chemical bonding then.
Okay.
Okay, you do the first page for me first. The question, basically question 1 to 4 lah. Okay, do question 1 to 4 first.
For question 1, option A and B are the same.
Question A. Okay, skip question 1 first. Yeah, just do 2, 3, and 4.
Okay, I'm done.
Okay, what's your answers?
A, C,
A, B, A. Okay, A, B,
A.
A, B is correct. Sorry?
I wrote A, C, A.
Oh, you wrote A, C.
Yeah.
So question 3, you got it wrong, is it?
And for question 2, I just guessed, like, how do you know that magnesium oxide has a 100%?
Okay, we go question 2 first. So electrostatic force, right, is stronger when there's a greater charge difference. So for example, if I give you sodium chloride, Na plus Cl minus. See, the charge difference is from plus to minus. However, if you see magnesium oxide, Mg2 plus O2 minus is from plus 2 to minus 2, or 2 plus 2, 2 minus. So there's a greater difference in the charge here.
Oh.
Okay, so if there's a greater difference, that means you have stronger electrostatic forces.
Okay, then why is
Can?
it
Sorry?
why isn't it C?
See, rubidium is group 1.
Okay.
So it's Rb plus and then O2 minus. Okay, then for question 3, which statement shows that diamond and graphite different forms of, okay, put C. Okay, this right, graphite, okay, this right doesn't say that they are of the same element, because one can be a graphite could be metal, you never know, while diamond could be a carbon only, because this does not say that they are of the same element. Okay, because a lot of things can conduct electricity. Okay, so the correct answer should be B, where complete combustion of equal masses of each product produces equal mass of carbon dioxide as the only product. That means that this compound only contains carbon, because combustion is just the addition of oxygen. Combustion is addition of oxygen. Can understand?
Yeah.
Yeah. Okay, then can I get you to do the question 5? 5 to 7? A7. Yeah, 5 to 7. Huh? Hello, Kivion, can you hear me?
Yeah.
Okay, do you have a camera?
No, because I'm outside now.
Okay. Okay. Do you have the questions with you, the booklet?
Yes.
Okay. Have you done it?
Not all, but yeah.
Okay. Then in the questions that you have done, do you have anything you're not unsure you want to ask?
Yeah.
Yeah.
Isotope.
Sorry. Okay.
don't really
Is there a
understand
specific
isotopes.
question or
Like, I don't know. I don't really understand isotopes in general.
in general? Okay. Okay. Wait. So there's no particular question you want to ask, is it?
Yeah.
Okay. Then Prisha, you continue doing first, okay? Let me answer Q&A. So let me see, is there a question I can use? Okay, so for example, can you see my screen?
Yeah.
Okay, wait, let me go through question 21 for you. So, okay, what do you understand by the term isotope?
I think it's same nuclear number and same.
Okay, so isotope, right, is the same element with same proton number but different neutron number.
Okay.
Okay, so it's the neutron number that is different.
Okay.
Okay, so this question 21, do you know how to do?
Yeah. The top one is a nucleon number, right?
Top one is yes,
What's isotopic
the mass number.
abundance?
So
What's isotopic
basically
abundance?
basically, right, that means 60% of P, right, exists as P150. So there will be total of 100%, right? 60% of all the P exists as P150. Then X% of all the P exists as 155. So the question is asking you find X and Y.
I don't know how to do it.
No, okay. So do you know how to find relative atomic mass?
Yeah.
Okay. How do you find it?
It's just the periodic table and the number at the
Oh,
bottom.
okay, it's not okay. Wait, let me see if don't hang. Okay, let me see. Find an example. Okay, for example, question 13. This question 13. Have you done this question?
No.
You haven't do. Okay. Okay. So basically, right, how you do this kind of questions, right, is if they ask you to find relative atomic mass, it's not as simply as just looking at the periodic table. Okay, you have to calculate it. Okay, so in this case, what you have to do is boron, you exist as boron 10 and boron 11. So what you do is you take 10, the mass number, times the percentage. So 19.7 over 100. Then you plus 11 times the percentage also, 80.3 over 100. Okay, this will give you, if you type it into your calculator, 19.7 over 100. Okay, this will give you 10.803. So 3SF equals to 10.8.
Okay.
Okay, so the answer is C. So this is how you calculate it.
Okay.
Okay, got see this formula before?
Yeah.
See before, okay. Then we're going back to question 21. Can you try doing question 21 first?
Okay.
Okay, you try. Okay. Then I go back to Prisha. Prisha, which have you done?
Yeah.
Okay, 5, 6, 7. 5 is B, 6, the answer should be C, and 7, the answer should be C. Did you get any of these wrong?
My 5 is C and my 6 is B.
Okay, so 5 and 6 wrong, is it?
Yeah.
Okay, so for question 5, right? Which of the following sets of solid include giant metallic structure, macromolecular structure, and simple molecular structure? Okay, so giant metallic structure, right? All you need to do is find a metal. Macromolecule, do you know what is macromolecule?
Yeah, the giant molecular structure.
Okay, okay. Basically, it's your strong covalent bond one.
Yeah.
Okay, there's only a few compounds that you need to know. Do you know what are they? What are they?
Graphite, diamond, and silicon dioxide.
Okay, so graphite is made of carbon. Diamond is also made of carbon, and then Si, silicon dioxide.
Yeah.
Okay, so you put C, is it?
Oh, wait, I got my mistake.
Oh, okay. Yeah, then I move on to question 6, okay? SiO2, similar structure to diamond. Bronze is an alloy of copper and tin. Which statements about SiO2, bronze, and diamond are correct? All are bonded covalently. This is definitely wrong. Because bronze or diamond, sorry, bronze is a mixture. Alloys are mixtures. Okay, so they are not bonded covalently. Say all except bronze does not conduct electricity when solid. So this is correct. Diamond don't conduct electricity. Silicon dioxide also don't conduct electricity when solid. Okay, all have high melting points. This is also correct. So the answer should be C. Can? Okay, then can I get you to do question 8 and 9?
Wait, Joe. You know
Okay,
the
yes,
question,
Kiva.
question 21, right? If you have like X and Y, so how do you find X?
Okay, how to find X, right? So, okay, so P150, right, is 60%, correct?
Uh-huh.
So the remaining, how many percent left?
40.
40%. So what you do, right, is you take this as X.
Uh-huh.
Okay, then what will Y be in terms of algebraic expression or algebra?
Y.
X plus Y is 40%, right?
Uh-huh.
So Y will just be 0.4 minus X.
Yeah.
Can you understand this part? So this is basically doing algebra already. Yeah. So 150 times 60 over 100 plus 155x plus 1157 times 0.4 minus x. This is equals to 152.4. So it takes a bit of algebra.
0.4 is from 40 over 100, right?
Yes.
Okay. Then I know how to do it.
Okay, that's why the answer. So if you work it out, the answer will be C lah. Okay, so X will be 20%. Okay, do you have any other questions other than isotopes?
Yeah, the giant molecular structure, all those stuff.
Do you have a specific question?
Like, how do you know which one is which? Like, what bond is what?
What bond is what? Okay. Okay. Let me just use this space here. Okay. So this one pretty sure you can listen in also. Okay, so for ionic compounds or ionic bond, this is between a metal and non-metal. Okay, covalent, you split into two. You have your simple molecular structure, you have your giant molecular structure. Okay, But covalent, right, in general, is between a non-metal and a non-metal. Okay, then for giant molecular, right, there's only a few you need to know. Diamond, graphite, and silicon dioxide.
Then the rest will be simple molecular.
The rest will be generally simple molecular, unless the question states otherwise.
Okay.
Okay, then you have last one is metallic bonding. This is just metals lah.
Okay.
Can?
Yeah.
So if I ask you, HCl, is it simple molecule? HCl, what kind of bonding present? Or what kind of compound is it? Hydrogen chloride. Is it ionic, covalent, or metallic?
Be
Covalent.
wait, hydrogen. How you know hydrogen? It should be ionic, I think.
Hydrogen is a non-metal.
Oh,
Cause
then it
hydrogen
should be-
gas.
Yeah, then it should be
So
ionic one.
okay, ionic is between a metal and non-metal. Hydrogen is a non-metal. Chlorine is not a
Wait,
chlorine
never
is a
mind.
non-metal.
It's covalent.
So this should be covalent.
Yeah.
Okay, let me give you another one. For sodium chloride, is it ionic, covalent, or metallic?
Should be ionic.
Okay, correct. Sodium chloride is ionic because sodium is a metal, chlorine is a non-metal.
Okay.
Okay, last one. Let's say I have iodine gas. What kind of bonding is this? Is it ionic, covalent, or metallic?
Yeah. It should be covalent.
Okay, covalent, very good. Because iodine gas, right, exists as diatomic. Iodine is bonded to iodine. It's a non-metal and non-metal. So it's
Okay.
covalent. Okay?
Okay.
Okay, other than that, do you have anything?
Um,
Oh,
so it's those three and then the last one is metallic bond.
yes.
Okay, got it. Wait, I just copy down first.
Sure. Prisha, are you done?
Yeah.
Which two questions did I give you?
On 8, 9.
8 and 9. Okay, 8, the answer is A. 9, the answer is D. Do you get it correct?
9, I got A.
Okay, wait. Kivyon, are you done copying?
What's SiO2 in like word? Silicon.
Silicon dioxide.
Okay, thanks. Yeah, I'm done already.
Dioxide. Okay. 8 and 9. Okay, 9 you got it wrong. Okay, so bonding total number of electrons in covalent bonds for phosphorus. Okay. So in one bond, right, how many electrons are there? Let's see down here. How many electrons are here?
1.
Okay, here, right, in one covalent bond, okay, covalent bond is sharing electrons, right? One pair of electrons are being shared. So one pair means 2 electrons. So very simply, you need to count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 15. 15 times 2 equals to 30. 30. Can I understand, Prisha?
Yeah.
Okay, then let me see. Can you do 20 to 24?
Okay. I don't know how to do question 10.
Sorry, say again.
I don't know how to do question 10.
Question 10. Okay, let me see. Okay. Graphene is an allotrope. Do you know what's an allotrope, both of you?
Yeah.
Okay, what's an allotrope?
Like contains carbon, like
Okay.
diamond, graphite, and silicon dioxide.
Okay, allotrope basically means, right, they are made up of same element, but different structure. Okay, so for example, diamond and graphite lah. These two are allotropes. Okay, so allotrope, okay, so they say they have similar structure to graphite. Basically means it has the same chemical properties. Okay, so does graphite have giant molecular structure?
Yes.
Yes. Does graphite have high melting point?
Yeah.
Yes. Is graphite slippery in nature?
Yes.
Yes. Can graphite conduct electricity in solid state?
Yes.
Yes. So if all four have, the answer is D. Because graphene and graphite will have similar properties because they have similar structure. Okay. But if you compare diamond to graphite, then it's different already. Because diamond and graphite have different structures.
Which one is slippery again now?
Okay, so this one, right? Graphite.
Mhm.
Remember graphite? Because graphite, if you see, let me try to draw the structure. It will look something like that. My drawing not very good. Okay, then you have your weak IMF in between the layers. Remember?
Yeah.
So this weak, IMF basically intermolecular forces. Weak IMF require very little energy to overcome, so you can slide past one another, making it slippery.
Graphite.
Graphite and graphene will also have this.
Okay, got it. Thanks.
Because they have similar structures. Okay, Kevon, you all got any other questions you want to ask?
No.
Okay, have you done question 20 to 24 for chem bonding?
Wait, give me a while.
Okay, can. Okay, if you haven't done it, you can just quickly do it first, then we can go through together.
Okay.
I'm done.
Okay. Kivion, you done?
Not yet. I got 2 more questions.
Okay. We wait a while. Okay.
Okay, done.
Okay. Okay. So 20 should be D. 21 should be A. 22 should be B, and 23 A. 24 C. Okay. Let me make this smaller. Okay. Did you all get any of these wrong?
I got 20 and 22 wrong.
20. Let me make this 20.
Can
How
you
about
repeat
Prisha? Did you get any of these wrong?
the answers?
The answers are the one in blue.
Oh, I got 21 and 22 wrong.
21, 22. Okay. Okay, let me go through these 3 questions then. Okay, so 23, 24, both correct.
Yeah.
Yeah.
Okay, okay, so ammonia dissolves in water. Okay, what is the bond between ammonia molecules and water molecules on the left-hand side? Okay, ammonia, what kind of compound is it? Is it ionic, covalent?
I think it's covalent.
Okay, it's covalent. It's covalent, and okay, so is it simple or giant? Is it a simple molecular structure or giant molecular structure?
Simple.
Simple, yeah.
Okay, simple, correct. So simple, right? You have intermolecular forces of attraction. Forces of attraction. Okay. This is also called van der Waals. Okay, both are the same thing. Okay, water is also a covalent compound and is a simple covalent structure. So it will also have intermolecular forces of attraction. That's why the answer will be just D. Can
Fine.
you understand?
Understand.
Sorry, Prisha, you asked something?
No.
Oh, yeah, just ask.
Huh? No, I didn't ask anything.
Oh, wait, did Kivan ask something?
No, I understand already. Wait,
Understand,
okay, never mind.
And
I
then
thought they asked the bond between ammonia and water. So it should be in between them, right? Not in the.
Oh, no, basically what this means is, right, is between, in ammonia itself, what are the bonds inside? In ammonia. Then in water, what are the bonds inside water?
Okay.
Between the water molecules
Got
and
it.
between ammonia molecules.
Okay, thanks.
Okay, moving on to 21. What is the bond between nitrogen atom and hydrogen atom in the ammonium ion? Okay, ammonium ion is NH4 plus. Okay, so in this, right, okay, IMF is between the molecules. So for example, if I have N ammonia, this is one molecule, then I bond to another ammonia. This is your IMF. But within the molecule, that means between nitrogen and hydrogen, right? This is your covalent. Okay, so for 21, the answer is A. Is covalent bond. Can you understand?
No, I don't really get this one.
Okay, which part do you not get?
Like,
Is there a
cause the
specific
first
part?
one. The first one, what is it? This one you say the
Okay,
IMF is between molecules, then the first one, why is it not between molecules?
the first one is between molecules. Basically, NH3, right? This is one molecule, and then This is another molecule. So this is IMF. Same for water lah. H2O and then H2O. Drawing. Then this is H2O also. In between, this is IMF. However, they are talking between nitrogen and hydrogen atom. So within the molecule itself. So we have nitrogen. There we have. Okay, so this is the general structure for ammonia. So this bond between nitrogen and hydrogen, this is actually a covalent bond.
Oh, okay, yeah.
That's why they are considered covalent compounds as well,
Okay, got it.
because they have covalent bonds. Can you understand? Both of you?
Yeah.
Can Okay. Prisha can?
Yeah.
Okay, moving on to 22. What best describe bond between ammonium ion and hydroxide ion? Okay, so this is between ammonium ion and hydroxide ion. So ion, right, will just be electrostatic forces of attraction. Okay, and this is ionic.
Oh, okay.
Kivyon can?
Wait, no, I don't get this one also.
Okay, basically, right, if they talk about ions or anything with a charge, for example, they talk about sodium, chlorine, sodium ion, anything with a charge, it will be ionic bonding. Or it will be electrostatic forces of attraction, which will lead to ionic bonding.
Yeah, what's the electrostatic forces of attraction?
This is basically the attractive forces in ionic bonds. So between, for example, sodium chloride, right? Between sodium and between chloride, there's strong electrostatic forces of attraction between the sodium ions and between the chloride ions.
But I thought
Okay.
covalent bonding can also have ions.
Covalent bonding is generally between the atoms. So for example, let's say diamond, carbon, 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 got one more behind. So it's between the carbon atoms. It's not between carbon ions.
Oh, okay.
Okay, that's why we say that they share electrons. They do not form ions. They do not lose the electron. They share the electron. That's the difference.
Okay.
But I thought NH4 and OH. Oh wait, never mind.
Okay, this one, right, is between the ion. So NH4 plus is this whole ion bonded to another thing.
So ion is the after it like fuses together.
Yes, after it forms ammonia, basically after it forms NH4, it becomes an ion. Then this entire ion will form an ionic bond with something else.
Oh, okay. But the ion for covalent bonding can also be called molecules, right?
Sorry, can you repeat your question?
The ions for covalent bonding can also be called molecules, right?
Okay, for covalent bonding, there will be no ions. It's just molecules. So this is ammonia molecule, ammonia molecule. This is ammonium ion. There's a difference. Okay, so covalent bonding, they do not form ions. They only form molecules.
Okay.
Okay, then same thing for ionic. Ionic, right, don't have molecules, only have ions.
Okay.
Can Okay, no further question. Then have you done 25?
No.
Okay, can you just spend like 1 minute, do 25?
I'm done.
Okay, Kieran, you done?
Yeah, done.
Okay, the answer should be B. Did you all get correct?
I got C.
Okay, let me just go through. So hydrogen chloride, this is HCl, has a lower boiling point than calcium chloride, CaCl2, as covalent bonds are weaker than electrostatic forces of attraction. Is this correct? Why do you, okay, you all didn't choose this. So why do you all think this is wrong?
Because it's weak intermolecular forces of attraction.
Correct. This should be IMF, not covalent bond. Okay, so B is the correct one. So I just, Gareth, this person, I'll skip this first. We look at Vanessa first. In the formation of calcium oxide from its elements, 2 pairs of electrons are transferred from calcium to oxygen. They said 2 pairs.
No.
This is the tricky part. It's 2 electrons, not 2 pairs of electrons.
Yeah.
Okay. Then look at Wilson. Ionic compounds are only able to conduct electricity in the molten and aqueous state due to the presence of mobile electrons. Is it electrons?
Oh, ions.
Yes, in the presence of mobile ions. Okay, so the answer should be only Gareth is correct because it's sample of methane. Van der Waals is the same as IMF of attraction between any 2 methane molecules are weak. Okay, so the answer should be B.
The last one, right? For metallic, it will be mobile electrons, right?
Correct, metallic is mobile electrons.
We got it. Thanks.
Okay, time 53. Can we do one of the, okay, let me choose a, okay, let's not do this. Okay, let's do 28. 28 will take, it's a bit, okay, let me just go through lah. I think we don't really have time to, okay, let me see. Okay, 28. Describe and explain the trend in atomic radius of the elements in period 3 as shown in graph 8. So graph 8 is this. Can someone tell me the trend? What's the trend? Across the period, atomic radius increase or decrease?
Decrease.
Okay. Atomic radii or radius decrease. Okay. So going back to the question. So decrease, then explain. Do you all know the explanation? Can you all make a guess? Okay. Basically, right? Okay, this is a concept that you'll learn if you study JC or Poly lah, if you do chemistry in the future. Okay, this will only come out in your section, the harder questions lah, but they'll give you enough information to answer. Basically, right, this is your nucleus, this is your electrons, for example. In my nucleus, right, what is inside my nucleus?
Electrons and protons.
Is electrons in my nucleus?
Proton.
Proton and neutron. What's the charge of proton?
1 plus 1.
That's the +1, correct? +1. How about neutron?
0.
Okay, neutrons in 0. So right, okay, so across the period, right, the proton increase or decrease? Okay, the number of protons across the period will increase. So if you look at period 3, right, 1, 2, 3, you have, write this down. This is part of the answer. So you have to write across the period, proton increase. Okay, you can just look at sodium and magnesium lah. Sodium got 11 proton, magnesium got 12 proton. Then aluminium got 13 proton. So your atomic radius is always, your number of protons is increasing. Okay, then you can see aluminium then, okay, decrease. Okay, so what happens when proton increase, right? nuclear charge increases. Okay. So nuclear charge, right, is the charge, because proton is charge of +1, right? This contributes to the nuclear charge. So more proton, that means your nuclear charge is stronger. If your nuclear charge is stronger, the outer electrons or valence electrons will be strongly attracted to nucleus. So if my electrons are strongly attracted to the nucleus, right, it will go closer to the nucleus, causing the atomic radius to decrease.
Okay, so the nuclear charge is the amount of +1.
For now, you can take it as that.
Okay, thanks.
So just need to remember that nuclear charge is affected by the number of protons. So more protons, that means you have a stronger nuclear charge. Okay, then okay, this is A. Okay, have you copied this? I erase, huh?
Okay.
Yeah. Okay, then if you look at B, comparing atomic and ionic radii of the elements in graph 8. So if you look at graph 8, atomic radii and okay, so sodium and where's my other sodium? Sodium and silicon, silicon here, there's silicon here. Okay, this should be sodium, this one. Okay, sodium and silicon, right?
That one's a
sodium,
typo.
magnesium, sorry, yeah, this one is typo, should be a typo,
Okay,
should be sodium. Okay, so these four, right, actually their radius decreases, can you see? While the rest, right, the radius increase. Okay, so that's what, let me see, comparing, okay. So first, right, you have to explain why sodium to silicon decrease. So very simply, right, let's take the example of let's take the example of sodium. Sodium atom, right, let me draw. Sodium atom will look something like this. 2, 8, then 1 outermost. Correct? So if sodium, how does sodium form an ion? Anyone? How does sodium form ion?
Well,
Hey, Kivion?
covalent bond. Yeah, covalent bond, I think.
Okay, formation of ion, right, is not about your bonding. Prisha, do you know how does sodium form ion?
It loses one. Sorry, it gains one. Wait, it loses one.
Gain or lose? Loses one, correct. So for sodium, okay, basically to form ions, right, you either gain or you lose electrons. So for sodium to become sodium ion, you lose one electron. So you see the outermost one, you lose it. Okay, you become sodium with a charge of plus.
Oh, okay. Understand already.
Okay, so comparing these two, right, sodium, the radii, right, is from the last electron to the nucleus. Same for the ion, the last shell to the nucleus. So if sodium atom has one extra shell, so the radius will be bigger. Then when it becomes ion, it loses the outermost shell. So when it loses the outermost shell, the ionic radius decreases. Can you understand?
Yeah.
So this is the explanation for sodium to silicon. Okay, then for phosphor to chlorine, right? This part, okay, you all write it down in words. Okay, I just briefly say it. Anyway, sorry, okay. Then for for phosphorus to chlorine, this is another concept that you all will learn in further if you continue chemistry in the future lah. Okay, but basically from P phosphorus to chlorine, right? Number of electrons increase. Correct? Because as more protons, you have more electrons. Okay. Okay, so when there's more electron, it will be less attracted to your nucleus. So if your electrons are less attracted to the nucleus, you'll be further away from nucleus. Therefore, your radius will increase. See, this concept is called electron shielding, where the electrons will repel the nucleus. Okay, but for now, this is all you need to know. As number of electrons increase, you'll be less attracted to the nucleus. That's why your radius will increase. Can you understand?
Yep.
Okay, can understand?
Yeah.
I understand.
Okay, so time actually is 7 now. So so next time, right? Can I get your the next time if we have this Zoom meeting again, I need you all to complete the questions beforehand, okay? Because if you all don't complete, then come prepared, basically. Come prepared and ask questions. Because this is supposed to be more of a consultation instead of you all do, then I go through on the spot. Okay. So it's better for you all next time to prepare, do the questions beforehand, and then prepare questions to come and ask me. It'll make the lesson a lot better, a lot smoother. Okay?
Okay.
Can okay. If not, we can end the lesson here today. Thank you. Yay, end. Yeah, but Kevin come like 1 hour late.